there was a lot of lost product due to the way that the rackings were built and structured. So here we go through our flow chart. This is the process that the pickers go through for the accessory department. They first start off by walking to where the carts are held, and they'll stay in a cart with empty boxes. Then they'll go through the path of the different racking locations. From there, when they end picking, they'll go into the induction line, which there they'll induct all the full cases, and if there's more product to be picked, they'll go through the process again. If not, that'll end their shift, or they'll go to transfer to another department. So here's our current state layout. Starting at the top left is where the pickers come into the department, and the yellow line represents their pick path throughout the whole entire accessory department. One thing that we did notice was that there was a lot of time wasted on the orange section right here, just walking around the rack, because there was an obstruction from this conveyor belt to this racking where they could not go through. So that is one thing that we wanted to focus on, was the layout, to try to minimize the amount of distance they have to walk just to go to the induction line. So here we have our value stream map. We noticed from the data that we received that the company was receiving about 37,000 units a day from receiving to the accessory department, and it took about an average of 2 days from when the product was picked to be shipped out of our warehouse to go to the stores.
So we did a root cause analysis to figure out which ones were the causes causing the company to not be able to meet their demand of 174,000 units a week. So we came up with 7 different causes. The ones highlighted in red are the ones that we will be focusing on, because based on our time studies, our observations, and our interviews, these were the ones that showed that there's a fraction of the processing time spent in searching for product, maneuvering the material handling equipment to transport from one location to another. Also, there was time spent maneuvering the material handling equipment, and the last thing was in walking. There was a lot of time spent just in walking from one location to the other.
So we decided to come out with 2 alternatives for our layout. So the first alternative, we decided to keep the cart storage as well as the conveyor centralized. This helps so that generally pickers have the same route where they have to go to every rack location, but sometimes they do have orders where they only go to specific rack locations. So with the centralized conveyor, it's easier for them to do their quick route and then just drop it off right at the conveyor. The other thing we had to keep in mind was that the blue rack is fixed because there's a conveyor right above it, so we couldn't really move that, so we try to utilize the space as much as possible. So with the second alternative, what we did is we decided to remove the conveyor. So now pickers had to drop off boxes over on the left side where there's a conveyor. So same thing, we kind of mimicked the blue rack that was fixed, and we try to utilize the space even more so that we can minimize the walking distances. They're non-value added. So comparing the 2 alternatives, we can see that we reduced the first alternative by 62% in non-value added walking time and distance, as well as 78% for alternative 2 in their non-value added time and distance as well.
Through further research, we were able to determine our second bottleneck, which we referred to as the blue racks. In this area, the processing time is being spent at about 70%, and within this 70%, 50% of that time is being wasted by trying to look for misplaced product and maneuvering the cart along the picking path. This image helps us portray the fact that this area itself is highly unorganized, which increases picking path, injury incidents, and decreases quality assurance. In order to improve the situation, we decided to recommend the implementation of movable propylene dividers, which will help the department cope with fluctuation in demand, as well as help them designate each location for each product, which will help decrease the searching time from 25 to 10 minutes. Continuing with this, in order to get a better visual, this will be the rack once the dividers are placed. 3 to 4 dividers are to be placed on every shelf, which will help reduce the loss of product which they face on a daily basis, as well as help eliminate the use of cardboard boxes that is being one of the struggles and creates clutter among the department. Our second improvement is considering the use of the cart that helps the pickers carry about 9 boxes from one end to the other. This cart itself, or the structure of it, doesn't allow it for it to be moved around in every direction, which adds the picker to struggle throughout the picking path. Also, if you consider the height of the structure, and if we add a box in the top shelf, then we will get a 6 feet height, which if we want to accommodate our 5th percentile female and 95th percentile male, then it's obviously, it lacks ergonomic implementations. In order to attack this, we decided to use the NEOSHA equation and OSHA recommendations in order to improve this. Our new cart system recommends the elimination of the top shelf. This is due to because by doing so, we will be decreasing any potential OSHA recordables, which can be caused by lifting heavy objects above eye level based on our demographics, as well as possible strains and other incidents that may cause an accident in the work area. As well, the last recommendation based on the cart will be to change the wheel casters. These are the ones that are currently used, and our new idea is to use these ones, which will allow a rotation of the cart on a 360-degree angle, and it will decrease the picking time on approximately 10 minutes.
So we decided to put this into simulation to model whether right now with their current state that they can actually meet their demand of 174,000 units per week. So and we took two things into consideration. We took into consideration the capacity of the cart. So right now they have a capacity of 9 boxes every time they're able to do a picking path. And now if we do implement the cart system, now we're going to be reducing that amount to about 6 to 7 boxes. So we wanted to see whether we can actually improve the production rate and decrease the amount of boxes being able to move throughout a picking path. So when we did that, we actually were able to see that right now with their current state, if they do not implement the cart system, so they still have the 9 capacity boxes, their production rate is 223 units per hour. If they do implement, if they use alternative 1, which is changing the layout, also changing the rack system, so implementing the dividers, and lastly changing the cart system, which decreases the capacity of the cart to be 6 to 7 boxes, their production rate can increase to 250 units per hour for alternative 1, and for alternative 2, which is the one that we removed the conveyor, their production rate can increase to 257 units per hour, which is just a 7-unit difference. The other thing that we did is we decided to do workforce planning for the company. So taking into consideration that the worker doesn't work a full 10-hour shift, we were able to see that right now with their current state, they need 17 workers a day in order to meet the demand of 174,000 units a week. If they do implement alternative 1, they can actually reduce that amount to 14 workers, and if they implement alternative 2, they can reduce it to 12 workers. If the cart system, that is the capacity of the cart, is still remained at 9 boxes per picking path, they're able to decrease the minimization of workers by 1 more worker. Also, the company let us know that they have that their demand usually increases towards summer, so back to school season, as well as holiday season. So it increases by 10% for back to school and 5% for holiday season. So based on these 2 scenarios, we figured out how many workers they need in order to meet their demand. And for the alternative 1, they need 16 workers, and for alternative 2, they need 15 or 16 workers. And from here, we were able to see that the significant difference between alternative 1 and alternative 2 is very small. So now we will use the cost analysis to see which one's the optimal solution. Right now, at their current state, they're losing $105,000. $102,000 from this is just their opportunity loss because they're not meeting their weekly demand.
So with the initial investment cost analysis, what we did is we analyzed both the improvements as well as the change of the layout and the conveyor removal, and we saw that there's only an $860 difference between the 2 alternatives. So then we ran that through a net present value equation, and we found that with a 10% rate of return as well as 15% rate of return, there isn't really much of a difference with their net present value of over 5 years.
So okay, so the current state right now, their picking path is taking them 164.7 minutes on average. If we implement alternative 1, then we are able to decrease the walking time by 6.87 minutes. We're also able to decrease the maneuvering the cart time by 15 minutes and the rack system time by 27 minutes. So based on all these alternatives, we did different combinations and we figured out that alternative one will reduce the total time by 46 minutes, which is our optimal solution.
So our optimal solution is alternative one, like Itzel mentioned. We decided to keep the conveyor centralized as well as the cart storage in order to make it easier for pickers, depending on their pick path, to make it simpler for them. The total difference between alternative one and alternative two is only a 200-foot difference and a 3-minute time difference, as well as the $860 difference. So we figured that was gonna be the best alternative. And then acknowledgements, our advisor, as well as the professors that we ask questions to, and the entire IME department. Any questions?
Well, I've got a question and comment. So from an industry perspective, when you started to talk about the alternatives, I would have maybe interjected that, you know, one's got a cost to it, the facilities, and mentioned that you're gonna address it later on, because, you know,
Okay.
you know, me seeing something from one of my folks, I'm on the edge of my seat and sometimes I get distracted with what's the cost. Right, so you can kind of tell us there's marginal cost, and I'll show you later.
Okay.
And then I think with your alternatives, correct me if I'm wrong, I think you combined a couple of things with alternatives. One of the differences between the two alternatives was with the conveyor system without. I believe, it wasn't clear to me, that the cart improvement and the separators were part of both alternatives?
Yes, correct.
Okay, so again, that would have been an ability on your matrix to maybe show and summarize and say, okay, here's the differences between these two alternatives.
So just specify here that it's gonna be
Right.
part of everything. Okay,
Okay.
sounds good.
And excellent with their flow, and kind of my first thought was, is they're struggling with their margins, and I'm thinking, okay, now you're gonna ask me to invest money. And that's why I kind of got into that thought, is how much money, and then maybe I would have sat back and said, okay, I know alternative one's gonna have these components, it's gonna be the cheapest, but I'm gonna wait for you to tell me what the analysis is later on.
Okay.
So again, I like the areas where you touched, I like how you shared it as a team, so again, just some pointers on what I like to see when I.
Thank you.
Thank you.